use quantity exact humidity. We'll be knowing in detail about that one. So the contents are the basic definitions first. This is what is humidity, what is saturated gas or nothing but saturation humidity, what is relative humidity, then percentage humidity, humid heat, humid volume, dew point, then what is the use of humidity chart, what is the humidity chart and how to use the humidity chart in order to determine various quantities. Then wet bulb temperature and measurement of humidity, how to measure a humidity. There are three types of methods are there to measure humidity. So then principles of adiabatic saturation. So this one topic, then principles of wet bulb thermometry and also the derivation of Lewis relationship in this particular topic. Then what are the various equipments used for humidification operation like a natural draft cooling tower, forced draft cooling tower, all this we will be discussing in detail. Then what is first of all, what is humidity? So humidity is nothing but addition of humidity is nothing but amount of water vapor which is present in the surrounding atmosphere or surrounding air is called humidity. Okay, whatever we are feeling now, humidity. So that is whatever the water vapor or coolness or chillness we are feeling out, that is due to the water vapor addition. Okay, if you have in a summer, okay, for example, in a summer, usually this humidity levels will be very low. Why it is very low? There is no water vapor which is remaining still in the air. That's why it will be looking as a dry gas, very dry gas. So under dry gas conditions, we cannot stay for the long time. We want certain humidification inside that one. So there are certain home humidifiers are also there. Now technology has been much advanced. So they are using home humidifiers also. The similarly, what is humidification process? So the humidification process is nothing but at which the moisture or water vapor or humidity is added to air without the change of its dry bulb temperature is called humidification. So first, what is this wet bulb temperature? What is this dry bulb temperature? We will be seeing now. So the process of addition of your moisture or water vapor or humidity to the surrounding air without changing its dry bulb temperature is called as humidification. So in actual practice, what happens in the practical way, there is no pure humidification. Whether humidification is always accompanied with cooling or it will be accompanied with the heating of the air. Okay, air has to be cooled or air has to be heated. Absolutely, we cannot add the this much amount of water, vapor to the surrounding. This much amount of water vapor can be removed from the surrounding air. That is dehumidification. So we cannot do that absolute process like that. But we have to, something will be changed. Some temperature will be increased or decreased. For example, in the evaporative cooler
Sir,
or
your voice is breaking, sir.
desert cooler. Okay, whatever the coolers which we are using in our
Excuse me, sir.
household purpose. So that is while we are giving some water content to that one. So the water content will be flowing. Yeah, is now it's okay.
Yes, sir.
Is that okay now?
Yes, sir. Yes, sir.
Your voice is breaking exactly. My signal is good only. Signal strength is very good. Yeah. So this addition of water vapor or humidity or your so in general process, what happens? This absolute humidification process is not possible. So in practice, many of the conditions, whether the temperature of the surrounding air will be increasing or surrounding air will be decreasing. So in the evaporative cooler, for example, in the evaporative cooler or popularly called as a desert cooler, in this one, what happens in the evaporative cooler? We will use some pump to circulate the water content. Okay, in the backside of that cooler, there will be circulation of water from that honeycomb mesh like that one. So from that one. So what happens when air is just impinging from that particular circulating water? So some part of the vapors will be transformed to the surrounding air. Then what happens? The surrounding air temperature will be cooled down due to the addition of water to that one. So if the water temperature is cool, Okay, you will get a cool breeze, cool air you will get. If the water temperature is more, for example, if you heat the water and pour into the cooler, then what happens? According to the temperature of that particular water, we will receive the air. If water is that much cool means we will get a cool air. If the water is hot means we will get a hot air from the cooler. So nothing but that one. So usually in the humidification process, the water will be heated down, or surrounding air will be heated, or surrounding air will be cooled down. So for example, in the cooling towers, what happens in the cooling towers? In the power plants, steam power generation plants, what happens? This cooling will take place. Surrounding air will be given up some excess amount of heat to the surrounding air. During this process, whatever the steam will be there, that will be condensed, and it will give some amount of heat to the surrounding air. So then the particular air will be increasing its temperature. So one thing is evaporative cooling, in which air temperature will be cooled down, and in the cooling towers, air temperature will be increased, that is heated up the air temperature. So humidification involves both mass transfer as well as the heat transfer process. It is heat transfer also because addition of heat is there or removal of heat is there, and at the same time addition of water vapor is there and removal of water vapor is also there. So that's why we will call this operation as a both mass transfer as well as heat transfer process. So humidification involves the transfer of material between a pure liquid phase and a fixed gas phase. So material between pure liquid phase and a fixed gas means a surrounding air, and pure liquid phase means water usually. So this water is usually soluble in the surrounding air. Then the reverse of the humidification process, that is removal of water vapor from the surrounding air, is called dehumidification. So for that also there is a portable room dehumidifiers are there, room humidifiers are also there nowadays. So what is exactly going on in the humidification process, we will see, and then we will define what are the basic definitions. Okay, for example, in the cooler, for example, if you are saying there is a cooler like this. Inside the cooler, what happens? Some fan will be there. Some fan will be there. If you see the rear view or the backside view of this cooler, there will be some honeycomb like meshes will be there like this. So here some pump will be situated. This pump entirely, this cooler we will be filling with some water. Okay, this pump, what happens? Inside some pump will be there. This will be circulating your water and it will be throwing at top, and your meshes will be there. Onto this one your water will be flowing. When your fan is just blowing some air, so this air will carry surrounding water vapor. This water vapors will be carried by the air. Due to the carrying of this water vapor, whatever the temperature which is having by this water vapor, that temperature, okay, around the same temperature, the air will be coming at the same temperature to us. If this water is having a high temperature, we will get a high temperature. If this water is having a low temperature, we will get a low temperature or cooling temperature. So this is called evaporative cooling. Evaporative cooling, this one. Or we can say this is as a desert cooling system or desert coolers. So this is the example for humidification with cooling. Okay, for example, if you see the humidification with heating, so there will be some parabolic column will be there, especially in the steam power generation plants. What happens from the top to bottom? The water, okay, heated water or steam which is coming from the particular steam power generation plants. So this water will be flowing like this. Whenever the water is flowing like this, so surrounding air will be heated up. So this the water which is present in the heat which is present in the air, this water will be going to the surrounding air. Because of this one, the surrounding air temperature will be heated up. So this is the example for heating with humidification. So absolute humidification is not possible. Whether the surrounding air has to be heated and it has to be, or it has to be cooled down. So this is about humidification, how the humidification will happen. Now we have to see what are the basic definitions. So first is what is wet bulb temperature. what is wet bulb temperature, that is WBT. Then next one is what is dry bulb temperature. Temperature DVT. Then next is what is humidification. Then what is humidity? So it will be denoted by capital H. Then fifth one is what is saturated gas, or we can say this as a saturation humidity. Saturated humidity, HS. Then next is relative humidity. Relative humidity, then percentage humidity. Next one is percentage humidity. So this will be denoted by HA. And next one is humid heat. It is denoted by CS. Then next one is humid volume. It is denoted by VH. Then next one is dew point. 10th one is what is dew point. Then 11th one is total enthalpy. What is total enthalpy? So these are all the basic definitions which we have to clarify first in order to solve any problems, and in order to understand the concept first. Okay, the concept, introductory concept will be this one. Humidification is nothing but addition of water vapor or humidity to the surrounding air is called the humidification process. So humidity is nothing but amount of water vapor which is contained inside that particular air is called as a humidity. So the same thing, by choosing the same definitions, we'll be modifying a little bit. Modification will be there in accordance with that particular definition. So first one is wet bulb temperature. So how to measure this wet bulb temperature? We have seen in instrumentation and process control what is wet bulb temperature, what is dry bulb temperature. Then, for example, if you have, okay, in this chamber there is some water is there. Okay, same chamber. Once again, I'm drawing. Some water is there. So if some process is going on in this particular thing. So if you want to measure the temperature of these vessels, so first, for example, to measure a wet bulb temperature, okay, like this, wet bulb temperature, thermometer. This is also a thermometer. For example, this is wet bulb thermometer you are locating. Wet bulb thermometer is nothing but you will cover this entire thermometer bulb with some wick or cloth. Or wet cloth. Okay. If you are covering your thermometer bulb with a wick or wet cloth, then what about the temperature which is measured by this thermometer is called wet bulb temperature. So thermometer temperature which is given by this thermometer, the temperature which is given by this bare thermometer bulb without any covering, okay, without any covering of wick or cloth, is called as a dry bulb temperature. So the temperature, wet bulb temperature is nothing but the temperature read by the thermometer covered by the water soaked cloth or wick over which air is passed. So over which air is passed. If you want to measure the surrounding air temperature, the thermometer bulb, this thermometer bulb, if you are covering with some wick or wet cloth, then that particular temperature is called wet bulb temperature. If you want to measure the surrounding air inside this vessel, so the thermometer bulb, which is not at all covered with anything, only some radiation shields or something will be provided. Apart from that, nothing will be there to cover this particular bulb. The temperature measured by this dry bulb thermometer is called as dry bulb temperature. So dry bulb temperature is nothing but the temperature of air measured by a thermometer freely exposed to the air. Okay, but shielding and radiation against the moisture will be provided. So this wet bulb temperature, dry bulb temperature is called true thermodynamic temperature. Is called true thermodynamic temperature. This is about wet bulb temperature and dry bulb temperature. If you want to measure the surrounding air temperature inside some vessel, if you are covering your bulb with some wick, okay, so that the moisture, okay, surrounding water vapor can be just absorbed by this particular water cloth or wick, okay, this wet cloth, and absorbing, and it is measuring a temperature. So this temperature is called wet bulb temperature. Without any covering of this one, if the thermometer is measuring, the bare thermometer is measuring the temperature of the surrounding air, then it is called as a dry bulb temperature. So this dry bulb temperature is absolute temperature, or true thermodynamic temperature, we will call that one. I hope it is clear, wet bulb and dry bulb temperature.
Yes, yes.
Okay. The next definition is third one, which is humidification. What is humidification? So addition of water vapor to the surrounding air is called humidification. So the process at which the moisture in water vapor or humidity, moisture in water vapor or humidity is added to the air without changing its dry bulb temperature, dBT, without changing its dry bulb temperature is called humidification. So how to process out this humidification? The process at which the moisture in the water vapor or humidity is added to the air without changing its dry bulb temperature is called as humidification. Means what happens, for example, if there is a surrounding air like this. Okay, if you want to add some water vapor to this one, for example, this is a dry air. Okay, dry air. Dry air means no water vapor will be there. No water vapor will be there because of this dry air. So whatever we will feel without any humidification, the crack to our skin will come. Okay, because of this only we are applying some moisturizers like Vaseline or something like that. If air is that much dry, then we cannot live comfortably. So because of this reason, we have to humidify this particular dry air. To humidify, what happens? We will be supplying some water vapor. Okay, some water vapor from the surrounding streams. If you notice, the places where some beaches, okay, some sea or some rivers are there, the humidity will be very high. Okay, humidity will be very high compared to the places where there is no water ponds or some rivers or some oceans are like this. Okay, why that is happening? Due to the heat from the sun. So whatever the water which is there, it will be vaporizing. Okay, it will be vaporizing and it will be solubilizing inside this air. So then this air will be turned to the wet air. So that wet air is nothing but a humidity. So the addition of water vapor to the surrounding air is called humidification process. So this process is obviously associated with heating of the air or cooling of the air. Absolutely, in practice, this humidification, true humidification process is not possible. Only the surrounding air temperature has to be risen up or it has to be decreased depending on the water temperature. So humidification process along with heating or cooling is used in the number of air conditioning application. Whatever the ACs, coolers, everything we are using, that is nothing but the process called humidification process. So the reverse of the humidification process is called the dehumidification. Means whatever the water vapor which is there inside this air, if you remove this air water vapor, so then that is called dehumidification. Okay, removal of water vapor from the surrounding area is called dehumidification. Then humidification and dehumidification involves the transfer of material between the pure liquid phase and a fixed gas phase. Here the pure liquid phase is water, this one, pure liquid, and fixed gas is this air. So this will be fixed. Why? Because it is not solubilized into the water. Only this water vapor is getting and solubilized into the particular air. That is called humidification process. Addition of water vapor to the surrounding air is called humidification process. The next one is humidity. Okay, amount of water vapor which is present in, so this is denoted by capital H. So mass of water vapor carried by a unit mass of vapor-free gas. So that is nothing but air. Vapor-free gas means without any water vapor inside that one. Whatever the inert gas is there, that is called air. So mass of water vapor per unit mass of your vapor-free gas or air is called as humidity. So this humidity depends on the partial pressure. So humidity depends on the partial pressure. Depends on the partial pressure of the vapor. Partial pressure of the vapor. So partial pressure is denoted by small pa. So then we know that partial pressure, okay, pressure percentage is equal to volume percentage is equal to mole percentage. We know this for the gases. So especially humidity is referred only for the gases. We are measuring whatever the water vapor which is present in the surrounding gas. So humidity will be calculated as molar humidity or molar humidity we can say. Molar humidity is nothing but partial pressure of water vapor. A is a water vapor. Then B is gas or air. Inert gas or air is called B. So PA partial pressure of water vapor divided by partial pressure of gas. So this is equal to partial pressure of water vapor divided by if the we already know from the what this law Raoult's law. What is Raoult's law? Raoult's law is nothing but partial pressure is equal to vapor pressure into mole fraction in the gas phase, total pressure into mole fraction in the gas phase. For the liquids, partial pressure is equal to vapor pressure into mole fraction. Similarly, Dalton's law. So Dalton's law is nothing but sum of the partial pressure is equal to total pressure. PA plus PB is equal to total pressure. If PB, okay, according to this equation, if PA is going this side, then this will be PB is equal to PT minus PA. Okay, total pressure minus partial pressure of other component, that is vapor, is called as a this one. So total pressure P, for example, this is only P we are taking, not PT. P minus PA is called your partial pressure of gas or partial pressure of air. So this is molar humidity. This is denoted by H. Okay, if you want a mass humidity, why? Because humidity definition is amount of water vapor, kg of water vapor present for the kg of vapor free gas. So the same thing, H is equal to mass humidity or humidity. Generally this mass humidity is called as humidity. So H is equal to just multiply with, we know that pressure percentage is equal to mole percentage. So moles is equal to weight by molecular weight. We know this one. So weight is nothing but moles into molecular weight. So here partial pressure is nothing but moles only. So moles into molecular weight we have to multiply, into molecular weight we have to do. That is partial pressure of water vapor into molecular weight of water vapor divided by. So this is total pressure minus partial pressure of water vapor. So this is nothing but PB. PT minus PA is nothing but PB. So this is MB, where PA is equal to partial pressure of water vapor or water. So PB is equal to partial pressure of air or vapor free gas. Vapor free gas. Then if P is a total pressure, then MA is molecular weight of component A, which is nothing but water vapor. Then MB is molecular weight of vapor free gas or surrounding air. Vapor free gas or air. Okay, this is a mass humidity. Okay, in the molar quantities, that is nothing but partial pressure divided by total pressure minus partial pressure of component A. That is. So absolutely same formula. Only this partial pressures we are converting into the moles, or converting into the weights. by multiplying it with the molecular weight. Is that clear?
Yes, sir.
Yeah. So this is the humidity. So similarly, then all this next definition is
Saturated gas.
yeah, saturated gas or saturated humidity. That is fifth one. Saturated gas or saturated humidity or saturation humidity also we can call saturated humidity. This is denoted by H subscript S. Capital H subscript yes. So saturated gas or saturated humidity is the gas in which the vapor is in equilibrium with the liquid at the gas temperature. So what happens if you are transforming, okay, if there is a surrounding air like this, air is flowing like this, and you are having some water. You are having some water. So this water is just getting added to this surrounding air. So this air will have some saturation limit. So every person, for example, the number of classes are going on, 6, more than 7, 8, 9 classes daily, your classes are going on. You will be getting some saturation. Okay, oh, let the sir maybe stopping the classes. Why? Because my mind is already saturated. Same thing, if you are keep on going to add a water to this particular surrounding air, this surrounding air will have some capacity. Okay, after exhaustion of its capacity, it will be saturated. So according to the technical meaning, what it is saying, so the gas in which the water vapor is in equilibrium with the liquid at the gas temperature is called your saturated gas. So at this saturated condition, the partial pressure of vapor in the saturated gas is equal to the vapor pressure of the liquid. So this is whenever this water vapor is getting transformed into the air, so this will have a partial pressure, that is PA. When this is a partial pressure, then in this one water, okay, in the water condition, liquid conditions, water will have a vapor pressure that is called PA dash. Let us say this is vapor pressure of water vapor, vapor pressure of water in the liquid phase. This is partial pressure of water vapor in the gas. Partial pressure of water vapor in the gas. So that is PA. This is PA dash is partial pressure, vapor pressure of water. So at the saturated conditions or the maximum equilibrium conditions, what happens? This partial pressure will be equal to the vapor pressure of the water in the liquid phase. So the partial pressure of vapor in the saturated gas is equal to the vapor pressure of the liquid at the gas temperature. At particular temperature T, this partial pressure PA is equal to PA dash. Under such conditions, so PA will be equal to PA dash. That condition is called as a saturated vapor condition. Under these conditions, we can define saturation humidity HS. HS is nothing but, so what is H? We already know that one. H is nothing but your partial pressure divided by total pressure minus partial pressure is H. So if you want in absolute weight quantities, then this is partial pressure into mole fraction of A, P minus PA into MB, mole fractions and mole fraction. Similarly, this also we can define HS is equal to, so according to the definition of saturated gas is where partial pressure of saturated gas is equal to the vapor pressure of a liquid, okay, vapor pressure of water in the liquid phase. Similarly, this wherever the PA is there, that we have to replace with PA dash. So that is PA dash divided by total pressure minus PA dash, where PA dash is vapor pressure of the liquid water. Then same absolute saturation humidity we can define for the weight quantities, that is vapor pressure into mole fraction of component A divided by total pressure into weight vapor pressure into molecular weight of your component B. So this two. Okay. The partial saturation humidity is nothing but the gas in which the vapor is in equilibrium with the liquid at the gas temperature. Under such condition, the partial pressure of vapor in gas, saturated gas, is equal to the vapor pressure of the liquid at the gas temperature. Is called as your saturated gas. So just in this equation, we have to replace with partial pressures with vapor pressure. That's the only thing here. So where PA dash is vapor pressure of water in liquid. Vapor pressure of water in liquid. Total pressure P is a total pressure. PA dash is a partial vapor pressure of your water vapor. So this is nothing but PB dash. So partial pressure of your vapor pressure of your air. So that is this thing. Okay, I hope it is clear.
Yes, sir.
Yeah. Then next definition is sixth one, relative humidity. So that is relative humidity. Relative humidity. So that is denoted by H subscript capital R, HR, relative humidity. So it is defined as the ratio of partial pressure of the vapor to the vapor pressure of the liquid. So this is defined as the ratio of the partial pressure. So that is partial pressure of the water vapor that is PA water vapor to the vapor pressure of liquid water, that is PA dash at gas temperature, at that particular temperature, at whatever the temperature of the gas is there, at that temperature, this is the ratio. So that is relative humidity is equal to partial pressure is PA divided by vapor pressure of the same water vapor is called HR, relative humidity. Usually this will be expressed in percentage. So that is into 100. HR is equal to PA by PA dash into 100, where PA is called partial pressure of vapor and PA dash is called vapor pressure of liquid. So that is HR is equal to partial pressure by vapor pressure. Usually this HR will be, relative humidity will be expressed in a percentage basis. So percentage basis. So absolute, if HR is 100%, if humidity is 100%, HR. So 100% humidity means saturated gas and 0% humidity means no saturation or free gas. 100% HR means it is saturated gas. Already the gas is already saturated with the water vapor 100%. 0% saturation means there is no water vapor inside the gas. So that is called as a free gas without associated with any water vapor. That is free gas. Is that clear? HR?
Yes, sir.
Yeah. So relative humidity. Then percentage humidity. Seventh one is percentage humidity. Okay, for example, let us say what is the difference between relative humidity and then humidity, normal humidity. Why we have to define in many quantities. So humidity and relative humidity, for example, H and HR. So what is this is nothing but amount of water present in air or surrounding air or in the atmosphere. Air or atmosphere is called as humidity. And whereas similarly, the relative humidity is also one type of humidity. Okay, one type of expression of humidity. So why we have to express in the two different quantities? For example, humidity is the water content of the mixture of water vapor and other elements which are found in the air. And at the same time, relative humidity is the humidity or percentage of water, okay, water vapor in the air at the given temperature. This is percentage of water vapor in the air at given temperature expressed in percentage. So this is normal amount of or water content, water or content of water, we can say content of water vapor and other elements associated with air, other element found in the air is called humidity. Then why humidity is used? Humidity is used to determine the likelihood of precipitation, likelihood of falling this what we say rains, okay, coming the rains. precipitation. Okay, likelihood of having the fog or some dew, okay, which is there in the atmosphere. If the atmosphere will be foggy, if the atmosphere will be associated with some dew, if the atmosphere indicates that rainfall is going to come, how we will indicate that one? Using the humidity values only. So then what is the use of this relative humidity? So relative humidity is used for climate control, for climate control. And how it affects? It affects the health. Okay, health, our health, then what is our comfort and safety of humans. So relative humidity will usually reported by this climate weather monitoring stations. So they will say that likelihood of coming something, okay, so the pollutants are coming along with the atmosphere, the pollution levels are high or something like that. So they will be defining how our comforts will be there according to the humidity. If, for example, if the humidity is very high, what happens if some wood material is there? Okay, inside the home, if some wood material is there, for example, so what happens, due to this excess humidity, okay, large amount of humidity, so this humidity will be, water vapor will be transforming and attacking to the surrounding wood, and due to this attack, this will be forming some molds. Okay, it will be deteriorating this wood material. Same example, if you take, if the uh, humidity is very low, so on the other hand, humidity is very low, so without humidity, this wood material will be cracked down because there is no surrounding moisture. Cracks will be coming. Similarly, in our skin also, whenever we are living in the atmosphere where the very dry air is there, there our skin will be cracked. Okay, cracks on our skin will be coming. Okay, our skin will be very whitish color type of thing will be there. Deposits will be there because of this low humidification condition. If the moisture is very high, every time we will sweat down. Okay, sweating will be very high. Okay, that's why the control of humidity is very important. Okay, is that clear?
Yes, sir. Yes.
Okay, then next one is percentage humidity. Percentage humidity. It is denoted by HA, H subscript capital A. So it is nothing but a ratio of your actual humidity. Actual humidity is H. So HA is equal to divided by saturation humidity. So ratio of absolute humidity divided by saturation humidity. So usually this will also expressed in percentage, that is into 100. So now we know that H is nothing but, we know that MA into partial pressure divided by MB into total pressure minus partial pressure of component A. This is HS also, we know that HS is nothing but where partial pressure is equal to vapor pressure. Simply this equation we have to replace with partial pressures with vapor pressure. So PA dash divided by MB into P minus PA dash. So same thing we will be just substituting here. That is HA is equal to absolute humidity is nothing but MA into partial pressure divided by MB into total pressure minus partial pressure divided by MA into vapor pressure divided by MB into total pressure minus vapor pressure. Okay, this one. So now we can cancel out this MB. Therefore, the left out terms, so into 100 is there here. So your percentage humidity is equal to, left out terms are this partial pressure PA divided by this vapor pressure PA dash. Let us write this 100 this side, and left out terms are, this will be going to the extreme numerator, that is total pressure minus vapor pressure divided by, so this one is left, that is total pressure minus partial pressure. So we know that vapor pressure, partial pressure divided by vapor pressure into 100 is nothing but earlier equation we have seen. That is HR is equal to partial pressure divided by vapor pressure into 100 is nothing but HR. That is HR is equal to partial pressure divided by vapor pressure into 100. So same thing we will be calling this as HR. HA is equal to HR into total pressure minus vapor pressure divided by total pressure minus partial pressure. Okay, that is called your percentage humidity. Percentage humidity. So at all humidities other than 0 to 100%, the percentage humidity will be less than the relative humidity. So if the humidity is relative humidity is 100%, that is called saturation. Maximum capacity of your air has been reached. So that is 100% humidity. And 0% humidity means this is free gas. So there is no water vapor inside the air. In between this 0 to 100%, absolutely this percentage humidity will be less than the HR at this region 0 and 100%. So that is absolute humidity. I hope it is clear.
Yes, sir.
Yeah. Then 7, 8 is humid heat. So 8th definition is humid heat. So this is denoted by CS. So humid heat is nothing but the heat energy necessary to rise the temperature of 1 gram or 1 lb of gas and its associated vapor by 1 degree centigrade or 1 degree Fahrenheit is called your humid heat. So this is nothing but the amount of is the humid heat is nothing but is the heat energy necessary to increase the temperature of 1 gram or 1 lb in FPS units of gas and vapor together. Gas and vapor that it contains by 1 degree centigrade or 1 degree Fahrenheit is called humid heat. Humid heat. So this is, for example, if there is a air plus water vapor is there. If you want to rise this temperature, T is equal to, for example, 0 degree centigrade. This is, so this same air and water vapor temperature, if you want to rise this temperature to 1 degree centigrade or 1 degree Fahrenheit, okay, degree Fahrenheit, if you want to rise its temperature, so how much amount of heat you have to supply to rise this temperature is called as your humid heat. Thus we can say humid heat is nothing but sum of the heat energy contained by your vapor plus gas is called as your humid heat. So humid heat is equal to sum of the, that is specific heat of the gas plus specific heat of the vapor into vapor is already associated with some humidity. So that is humidity. So where CS is the humid heat, CPB is the specific heat of gas, that is air, gas or air. CPA is the specific heat of water vapor. So usually they will be measured in joule per kg Kelvin. So this is also joule per kg Kelvin. Then H is the humidity. Humidity of air, amount of water vapor which is present in the surrounding air is called humidity. So this is the formula for the humid heat. Sum of the heat quantities of air and water vapor is called humid heat. I hope it is clear, humid heat.
Yes, sir.
The ninth one is humid volume. Okay, it is nothing but the total volume of unit mass of your water vapor plus your air that it contains at 1 atma and at gas temperature is called humid volume. This is the total volume of a unit mass of vapor-free gas, that is nothing but air, and its vapor at 1 atmospheric pressure and at gas temperature is called humid volume. So amount of humidity which is contained, the volume of humidity which is contained by that particular vapor-free gas along with the vapor is called as your humid volume. For example, from the definition from this from the SI units, for example, if your VH is defined in SI units, we can use this formula from the ideal gas law. So humid volume is equal to 0.224 divided by 273 into temperature into 1 by MB, molecular weight of component A, air, into plus H is humidity divided by MA, molecular weight. So this is temperature. Temperature in Kelvin. This is molecular weight, humidity. This is, so this VH will be coming in meter cube per gram of your air. Meter cube per gram of your air. This much of volume is there for each gram of air. If the same SI units, if it is dependent on pressure also, if P total pressure is not equal to 1, okay, not equal to 1. Under such conditions, we have to use this formula. VH is equal to 8315 into 1 by MB plus H by MA into T plus 273 by total pressure PT. So where T is the temperature in degree centigrades and pressure is the total pressure in pascals. So now we will get in meter cube per kg of your dry air, how much volume of your humid volume is there inside the air. This you will get. And for example, if you want to go for FPS units, pounds per square inch units. Okay, in this system, VH is defined as VH is equal to 359 T by 492 into 1 by MB plus H by MA, where this T is a temperature in degree Rankine. Degree Rankine. So VH will be in feet cube per LB. Okay, feet cube per pound. Each pound of air, how much feet cube of your humid volume will be there. So, so this three equations you have to remember. Okay, you have to remember this equation. There is no alternative. So humid volume is nothing but the total volume of a unit mass of your vapor plus air at one standard atmo and gas temperature is called your humid volume. So in the SI units, if it is independent, if your total pressure is 1, you can use this formula. If your total pressure is not equal to 1, then you can use this formula. If the units are given in FPS units, then you can use this formula. Is that clear?
Yes, sir.
Yes, sir.
Okay. For example, if there is a vapor-free gas, whose vapor-free gas means humidity is equal to 0. And what about its humid volume? Its humid volume is nothing but its specific volume of the fixed gas or air, specific volume of fixed gas, or we can say it is nothing but air. For example, if there is a saturated gas, so saturated gas will have a humidity of 100%. Hs is equal to 100%. Then we can write H is equal to Hs plus humid volume. Then the saturated, it will become, humid volume will become H is equal to Hs. Then humid volume will become is nothing but a saturated volume. So if H is equal to 0, your VH will be the specific volume. If Hs is equal to 100 or H is equal to 100, then H is equal to Hs. Under such condition, VH is nothing but your saturated volume. And only two definitions are left, I think. Yeah, dew point and total enthalpy. So we will be seeing this in next class.